Hi, this is a tutorial on how to do the nomenclature that was on the discussion board. A lot of you made the mistake of using the atomic mass as shown in the periodic table. Remember that the atomic mass shown in the periodic table is the weighted average of all the isotopes for that particular element. For example, if you had two isotopes for chlorine, one that weighs 35, the other one that weighs 36, then they both exist at 50% abundance, then the average would be 35.5, and that's what you would expect to see in the periodic table. So when you see the atomic weight in the periodic table and you see that it's not a whole number, then it's because that particular element has a whole bunch of isotopes. So let's do this problem so that you can see that the way you solve this particular problem is by using the information that's provided. And for each of these chemical species, number 1, number 2, number 3, number 4, it's a particular isotope for that particular element. So we start with 115 right here. And you can see that 115 and 65, that's the two information that you can use. Now, what we can do is say that the proton plus the neutron is equal to the atomic mass, which happens to be, in this particular case, A. So the way you figure out the number of protons is you take 115 minus 65, and that happens to be 50. So the number of protons for this particular element, this particular isotope, is 50. And so now that we have the number of protons, we also have the atomic number. And if we have the atomic number, we also have the identity. So if we look over here for atomic number for 50, we can see that that happens to be 10. So that's going to be right here. Now this number right here tells you the proton to electron imbalance. The fact that it's a +3 tells you that you have more protons than electrons. So that makes the number of electrons 47, because 50 minus 47 equals +3. So we basically have all the information that we have to complete the nomenclature for tin. It would be 115, that's where you put the atomic mass, 50, and then don't forget the +3 over here. Now for the second one, we have the number of protons, so we already know the chemical identity. 35 happens to be bromine in this particular case. So we know this is bromine. We know it's -1, so we put that there. We also know that for this particular element, the number of neutrons, 45. So 45 and 35, that makes it 80. So the atomic number is the same as the number of protons. And atomic mass, oops, excuse me, I put that in the wrong place. This should be 80 here. And the fact that we have -1 tells you that there are more electrons than protons, so this makes it 36. 36 electrons and 35 protons gives it a net of -1. So the proper nomenclature would be 80, 35, and -1. For number 3, we have the atomic number, 88. So right away we know that this particular element is going to be, find that in the periodic table, radon. So we can just put that here. Now the number of electrons, that is just up here. Atomic number is the number of protons. And we can subtract 225. From 88, and that will give us the number of neutrons. So in this particular case, 225, 88, that gives us 137 neutrons. So, and then the fact that there are 86 electrons and 88 protons tells us that there is a net charge of +2 in this particular case. So we put +2 right here, we put 225 right here, and we put 88 over here. So that's radon. The last one, we have the information for gold, and then, again, this particular isotope is gold 198, so that's the mass. The number of protons for gold is 79, which is also its atomic number. We can assume this is neutral because there's nothing here. So we can say that the number of protons and the number of electrons are identical. That'll be 0. And then if we take 198 and subtract 79 from that, what we get is 119. So that's the number of neutrons for this particular species. So that's how you solve this particular nomenclature.